Hey guys, how are you? This is Nikhil, and I'm now up with a very good course for you, a new course for you for your preparation. That is fault analysis in power systems, and this is me, Nikhil Nakka, presenting you this course. Let's check out what is there in for you. So the target audience for this course are people preparing for GATE, IES, and PSU and other recruitment exam aspirants, and practicing power engineers can benefit from this course, and electrical engineering students pursuing UG and PG courses like BE, BTech, etc. can also benefit from these courses. Okay, and moving to the next slide, and this is me, Nikhil Nakka. Okay, you find this is me, and I'm a freelance professional GATE IES exam trainer, and I'm also a freelance R&D engineer for smart automation engineers for smart automation systems. And I'm also an Indian patent holder, and I'm a verified educator here on anacademy.com and category expert for GATE as well. I have made very good courses there for you to check out. Okay, and this is how my Unacademy profile looks like. Okay, please do visit. This is me. This is my profile, verified. And you see, I've already made like around 8 courses, and some more courses are ready to come. So one of the most wanted courses are like power systems and these topics related to electric circuits for your GATE or IES preparation. You'll find them really enjoying and beneficiary. And next thing is don't forget to subscribe my YouTube channel. Here what you're watching. Okay, this is my channel, how it looks like. Here is a subscribe button. You have to subscribe, and there are many more good courses here on my YouTube channel for you. Okay, make sure you subscribe for more updates regarding all my courses and further videos of this particular course also. Okay, now we will discuss what is fault analysis. Okay, regarding fault analysis subject, and first we will define what is fault. Okay, what is fault basically? Fault means if something is wrong, then you say it fault, as simple as that. So as far as electrical engineering is concerned, in electrical engineering, when do you say some fault has occurred? So we can tell that when current leaks, okay, when leakage of current takes place in the system. Or what do you mean by leakage of current? It means flow of current in an unintended path. Unintended path means the path which is not assigned for the current to be flown. For example, you take what is the path assigned to the current to be flown in any system? The path that is nothing but the conductor. Okay, why do you use conductor in any electrical apparatus or any electrical system? For to facilitate the flow of current. If the current flows in that path in the current conductor, then you say the equipment is working normal. And if that doesn't happen, if current leaks through the body to ground or something happens, or it flows through your body, you get an electric shock, right? Even that is a faulty condition. So that's called basically a small definition of fault. What happens when fault happens in a power system? Fault leads to failure of that particular apparatus where this leakage of current takes place. Okay, if current leaks from the system and if it is not attended, okay, if this leakage is not attended, what happens when water leaks in your house? You attend it, right, by getting a plumber, or if you know if what is the problem, then you will attend the fault so that the leakage can be minimized or leakage can be reduced. And if it is not attended, what happens? Then the equipment is set to fail. When equipment is set to fail, what happens after failure? After failure, usually what happens is generally melting of the conducting path in which the current was actually intended to flow will melt and it becomes open, and there will be no more path for the current to flow, either the fault current or good current. Then whatever power supply you're giving to the equipment, it will not take it because the path has been breaked, okay, break open, and the machine is said to be failed. Okay, so what basically what causes failure of an electrical apparatus is our point. Okay, we are just basically talking about failure, okay, fault which leads to failure. But first tell me what happens, what causes actually the failure of any electrical apparatus. So voltage fluctuations, okay, everybody agree. Now tell me, when you talk about voltage fluctuations, voltage fluctuations are high voltages and low voltages, two types, right? Now tell me which is dangerous or which causes the failure. Okay, tell me when failure happens, under high voltage condition or low voltage condition. Can you tell me? Just think and tell me. Let me tell you. So what happens under low voltage? Let's examine what happens under the low voltage condition. For example, let's take example of any load. What is your favorite load? Okay, let me take a ceiling fan. Okay, ceiling fan in a home. What's wrong with ceiling fan? Now let's examine what is the power consumed by this ceiling fan. It's a single phase device, so we can tell the power in this single phase circuit is equal to voltage into current into power factor of that equipment. It's not just it may not be any ceiling fan. I'm talking about any single phase circuit, any single phase device that we normally use in your home. So what happens under low voltage condition? So before that, you have to understand that any load, okay, any load will basically not compromise, okay, will not compromise for its power, okay. Any load will not compromise, okay, for power, okay. For example, you take a ceiling fan is usually rated at 80 watts. If it is rated for 80 watts, whatever may happen, anything may happen, it always tries to draw 80 watts. That means power is constant, okay. Basically in loads, power is constant. If you connect a load to the system, it always tries to draw its rated power. Now what happens is, now you are telling that voltage is decreased, low voltage. So assume that power factor is constant. Now power is proportional to voltage into current. If voltage decreases, to maintain the power constant, what happens to the current? Currents will rise. Current will rise. What happens when current will rise? You know, excessive current will cause melting of conductor, and then that also cause faults. And before that melting happens, what happens is insulation of the system will fail. Insulation of the system will fail. Of the system will fail when current rises. Why insulation of the system will fail? Why? Due to high temperatures generated in this process. Because high temperatures. Because when current value is raised, the I square R in the system will increase, which is nothing but heating effect. Okay, when the heat rises, the insulation will be subjected to thermal stresses and insulation will fail. What happens if insulation fails? If insulation fails, then automatically your current will be leaked. Okay, will be leaking. It will be leaking between two conductors of the system, or between the conductor or body. Okay, why do we actually need insulation in any electrical apparatus? Insulation is a very primary requirement before constructing any electrical apparatus or any electrical device. The reason is to avoid leakage of current. You know what insulation does? What an insulator? What is an insulator? Okay, which stops flow of current, right? Stops current. Okay, it stops current. The purpose of an insulator is to stop current. You know, the current is like a very childish thing. It always tries to flow wherever there is low resistance. For example, your machine is operating. Okay, there is a winding in your machine. Now you go and touch the winding. You are automatically connected to the ground because we are standing on the ground. And ground has a very little resistance as compared to your winding resistance. Then current starts flowing through you. You will get shocked. So to prevent that, what you're doing, you're going to place some insulation layer on your conductor. Similarly, in between the conductors, if in between the conductors insulation is not there, then current will get a short part and it gets short circuited, and it flows. It gets short circuited and it flows. It raises to very high value. So that is the main problem. So basically, failure occurs due to failure of insulation. So under low voltage condition, your insulation shall fail. That's what happens. So if low voltage causes insulation, then you have fan regulator. Okay, fan regulators. Why do you use fan regulator? To regulate its speed under. Now it's winter season here now. So in winter you need regulator to reduce its speed. What basically a fan regulator does? It does what is, it controls the voltage. Now you want the fan to rotate at a very low speed, then the voltage will become very less. Now if low voltage is there, what happens then? Current will be rising. Current will be rising. So don't you think the machine will fail at this condition when you are operating your machine at low voltage or low speeds? So basically every machine will have certain tolerance of temperature. So usually when you are decreasing the voltage, the current will be rising, the heat will be produced will be usually under that tolerance. So there will be a there will be a range of voltage, okay, from high level to low level, where the voltage can be reduced to the maximum. If your voltage will dip or go down more than that, then current will be rising to an abnormal value, which leads to production of abnormal amount of heat and again failure of insulation. But however, it is not advisable for you as electrical engineers, you know that low voltage will lead to high current in the system. Then operating your fans on low voltage or low speed for longer durations is not advisable actually. Okay, don't operate your fans on low voltage or low speeds for longer durations. For short time it's okay, but what happens when you operate on a long term basis? Your fan is not just going to fail right now, but its life is going to decrease because enormous amount of heat is being generated. However, that generated heat is within its dissipation limit, but heat is heat. Overall, over a period of time, its lifespan will decrease. So you better use this low voltage at the time of starting. But when you're running your fan for a long duration, just go for high voltages. That is good. Now let's examine what happens under high voltage. So now we were telling P is V into I cos phi is constant. Now voltage increases, now current will decrease. Now current will decrease means heat generated will be very less. Now it's very good. Now why will the fault occur or not? Yes, fault will occur here also because high voltage leads to again insulation failure. Insulation failure. Now I said that under low voltage also insulation is failing. Now why under high voltage also insulation will be failing? See, in fact, the purpose of insulation is to stop the flow of electrons. Everybody will accept with this definition. Okay, stop the flow of electrons. In order to stop the flow of electrons, it actually has to stop the force which moves the electron, isn't it? And what is that force? What we call EMF or voltage. It has to withstand that voltage. So every insulation basically is rated based on the voltage it should withstand. It should withstand. Insulation is a very important component of any electrical apparatus, and insulation is designed based on the voltage. Suppose if the operating voltage increases, then insulation will increase. What happens if insulation increases? Insulation is a very costly thing. The cost of that apparatus will increase. Okay, what happens when the cost of the apparatus increase? People will say it is not an economical device. And apart from cost, even the size of the size of the machine will increase because insulation is a bulky component. As the voltage increases, it becomes more and more bulky. You need to increase the size of your machine. So this is the effect of increasing voltage in terms of designing an electrical machine. If voltage increases, then you have to make sure that your insulation should withstand this voltage also in order to prevent the leakage. And if insulation increases, automatically cost and size of the machine also increasing. Now every insulation will be designed for a particular voltage. Say insulation is designed for 100 voltage, 100 volts. If the voltage applied on the insulation increases 100 volts, it may withstand. It might be having some 10% of tolerance. Okay, plus or minus 10 plus 10% of tolerance. Say up to 110, it can withstand. What happens if your voltage exceeds 110? It goes beyond 110. Then what happens is, just you can take a simple example. For example, there are two rooms. Okay, there are two rooms. These are two rooms. Okay, and there is a wall in between. Okay, this is the wall in between the two rooms. Now I am here. Okay, I am over here. I want to go into that room, but for me to go, this wall is stopping me. So this wall is an insulator now. Now I am an electron, and the force with which I am moving is my voltage. Now I'm just going there. This insulator is stopping me. I'm coming back. I'm going there, coming back, going there, coming back. But what if I'm coming with a very high force? Okay, very high force. Then this wall can withstand. Then what happens at one particular time? Impact takes place, collision. This wall will break, and I can happily move into that other room, right? Then the purpose of insulation is failed. Then insulation is said to fail. That is what happens if the force with which electron is moving, that is its voltage, is increased beyond a level with which an insulator can withstand. Then insulation will again fail. It will become a conductor, and this kind of failure is called as dielectric breakdown. Okay, so here also again insulation will fail. If insulation fails, again current will start leaking, high currents might enter into the system, and again all the nonsense will take place. Okay, now what is the failure of cause of failure of an electrical apparatus? So my answer is both high voltage and low voltage. Both are the causes of failure of any electrical apparatus. It's not good. Both can cause failure of any electrical apparatus. So that is the reason why the voltage has to keep kept in check. Voltage has to be kept in check. No, okay, voltage fluctuations are not good. Okay, the voltage fluctuations have to be minimized. So under ideal conditions, the voltage should not vary plus or minus by 5%. Ideally, the voltage should not vary, okay, at the terminals of any apparatus plus or minus 5%. If this happens, then the equipment will not function properly, and if the variation is too large, then insulation will take place. So failure of any electrical apparatus or any apparatus is basically nothing but the failure of system insulation. Okay, insulation fail, then you say the system is failed. Okay, the complete apparatus is out of service now. So in order to avoid the failure of insulation, what we have to do? We have to reduce the voltage fluctuations. It should be minimum. How much it should be? Ideally plus or minus 5%. And also Indian electricity rules will define how much variation of voltage is allowed basically in different voltage systems. So that we will discuss in another video. But ideally it is recommended that plus or minus 5% should not be exceeded in order to avoid failure. Now we are telling that insulation is failing, then machine is failed. How? We already seen insulation failure is in two ways. One is a high voltage way, the other one is a low voltage way. When it takes place at high voltage, you call it a dielectric breakdown. Under low voltage, due to excessive heat generated, it is called thermal breakdown. Please remember these points, very important for your competitive exams, especially if preparing for IES exam or SSC exam, such kind of exams, and this is a very important point. Now we will talk the definition of fault with respect to our power system. What is our power system? It's a very big system having a generating station, transmission lines, distribution lines, utilization, and all these things, So in with respect to power system, how can we define a fault? So this is the definition of fault. Let me read it out. If the insulation of the system fails, okay, if the insulation of the system fails, if the insulation of the system fails at any point, or if two or more conductors, okay, two or more conductors that normally operate at operate with a potential difference come in contact with each other, then a short circuit or fault is said to occur. Okay, read this properly. Okay, it is specifying two things. Okay, insulation of the system fails. Usually when insulation of the system fails, what happens? Conductors which are operating basically at different potential difference will come into contact, and then short circuit, which is nothing but a fault, is said to occur. Okay, please make sure you understand this definition very well. Okay, now classification of fault. Okay, there are basically two ways of classifying fault. The first classification is called open circuit fault. What happens in open circuit fault? Then the path of flow of current is braked. Okay, there is no leakage. Okay, in this kind of fault there is no leakage. Okay, there is no leakage because first of all there is no normal current flow only. Okay, the normal current which has to flow, that is only not flowing, then where is the question of leakage? No, normal current only. Why? What happens? For example, there is a three-phase system, okay, having three conductors like this. Suppose if open circuit fault takes place, so one line has been open, or say two lines are open. Okay, two phases are open, and the third one is okay. Or say three of the phases become open. Okay, reason could be anything. Okay, reason could be anything: melting of the conductor, or faulty operation of the switch connected to that circuit. So all this called, okay, open circuit fault. Okay, this is usually does not occur in the system much often, and it's not a fatal fault, or it's not a fatal, or it's not much dangerous, and we are not much interested about this. And what we are much interested is which causes more damage to the system. That is nothing but short circuit fault. And these short circuit faults, which we already seen the definition of short circuit fault, are classified into two ways. Okay, one is called symmetrical fault or balanced faults. The other one is symmetrical or unbalanced fault. Symmetrical or balanced fault also called as three-phase faults. Please keep in mind. Okay, symmetrical or balanced fault also called as three-phase faults. Okay, guys. Now, what are these three-phase faults? In three-phase faults, what happens in short circuit fault? The conductors, both the two or more conductors, get into contact with each other. Now, first wave is L. Okay, in a three-phase system, you have three lines like this. Okay, now if these three lines get into physical contact with each other, whatsoever the means, then this is called L fault. Now, next thing is LG fault. L. Okay, what happens in this? The three conductors will come into contact with each other at the same time. It will be connected to the ground. It fall on the ground. So this is what LG fault, and these both are called as symmetrical faults, and they are three-phase faults. Please keep in mind they are symmetrical faults and also called as three-phase faults. Why do you call it symmetrical or three-phase faults? When fault takes place, okay, fault current will be flowing in this system, isn't it? Fault current in each phase will come into existence in order to feed that fault. So these three fault currents will be equal. Okay, fault current in each phase will be equal. So when current in a three-phase system in each phase is same, you call it as a balanced system. And also, if a fault cause fault current to be equal in all the lines, then you call it as a balanced fault. Okay, and the other category is unsymmetrical or unbalanced fault. So now it is clear why do you call it as an unbalanced or unsymmetrical fault, because when this fault takes place, the current in each phase conductor will be different. So you see what are the different categories of this fault. The first one I'm calling it LG fault. LG means suppose there is a three-phase system. Okay, one of the line gets connected to the ground, or connects to the ground means fault takes place on one line. Fault is nothing but connection to the ground, leakage to the ground. So you call this as an LG fault. The next category is LL fault. In under LL fault, you have three lines like this. Okay, and two lines. Okay, any two lines get contact with each other, so that becomes an LL fault. The next one is LG fault, right? So you have two lines like this, they get contact with each other and these get connected to the ground. So this becomes our LLG fault. Okay, now you see under this condition, okay, when LG fault takes place, fault has taken place in one conductor. Now fault current usually will be very high, will be in only in this conductor. And normally these conductors, current in these conductors become zero, okay. So imbalanced condition. Even here, fault will be in these both conditions, but not here. Current will become zero. So imbalanced. Even here also imbalanced condition. So current will each phase will not be the same. Now when we talk the frequency of occurrence or number of times which fault occurs more, symmetrical faults or unsymmetrical fault, then these percentages are good. Okay, symmetrical LLL or LLLG all occur more or less often equally, and out of total number of faults occurring on a power system, they constitute only 3%, very little. Okay, they are, you can also say they are less frequent fault. Okay, they don't occur much frequently in a power system. Which occurs more frequently is this unsymmetrical fault, which is LG fault. You can say this is more frequent occurring fault. Okay, this is the most frequent occurring fault. 85% of the total faults on the power system are LG faults, and the other one is LL fault. Okay, line to line, they are about 5%. LLG faults are about 7%. Okay, you got to remember this these percentages for your competitive exams as multiple choice questions, and everything is important for you. Okay, there is nothing like which is not important. Everything what I'm presenting will be really very important. Now when we see the order of severity in the sense which fault can cause more damage. More damage means it can draw more current. Okay, very high, abruptly dangerously high value of current. Then three-phase faults is more dangerous. Okay, very dangerous. And the next dangerous is LLG fault, and then LL, and least severe is LG fault. So I can tell three-phase fault. What is the three-phase? LLL or LLG fault? Okay, LLG fault. Okay, they are most severe, and LG fault is least severe. And when we talk the frequency of occurrence, LG fault is most occurring and three-phase faults are least occurring. Okay, please understand this. Okay, both of the differences between occurrence and their severity. Okay, LG faults are most occurring but they are least severe. These are least occurring but most severe faults. Okay, so what are the effects of fault? What happens when a fault takes place in a power system? Okay, when a fault takes place in a power system, it may lead to having large voltages in the system or large currents in the system. What happens when large voltages or large currents? Large currents in the sense low voltage, right? Low voltage will be there in the system, which will lead to the insulation and subsequently equipment failure. This is a very important point. Okay, and when a fault occurs, it can make a balanced three-phase system to become an unbalanced system. What happens when a three-phase system becomes unbalanced? It will lead to improper operation of the equipment. Okay, any three-phase load, any three-phase motor or any three-phase apparatus is there, and it will not function properly. Improperly it will operate. Okay, so unbalanced system is highly undesirable in any power system. Okay, unbalanced condition is highly undesirable. Highly undesirable condition in any power system. And most important thing is it can block the flow of power. It may lead to power failure or power blackout. Okay, however, I will make something called as the reason for grid blackouts and some case studies. Some other day I will make a video regarding certain case studies of grid failures, what is called as power failure, what is power blackout, especially regarding the blockage of flow of power. Okay, and it most important thing, very important thing is it causes instability of the power system. Instability of the power system. What is the stability of the power system? It is the ability of any power system to remain in stable or equilibrium state when it is subjected to any disturbance. However, we will make another course regarding power system stability. Let me give a small idea. Okay, so every power system has a power limit. Okay, limit of power with which it can transfer without losing its stability. Okay, see, suppose you are a person, you are lifting some weights. There will be some maximum limit of weight that you can lift. If you're trying to lift weight more than that limit, then you will fall down, which is nothing but you become unstable. So that power is given by this equation, Vs Vr by system reactance X sine delta. You are well aware about this particular equation. So here Vs Vr is the maximum power you can transfer, P max, and this value, this maximum power is usually constant. Okay, the maximum power which a system can carry, it usually remains constant because the system reactance is constant and the voltages are usually maintained constant. So we can tell the power flow is directly proportional to sine delta, accordingly which you get a power angle curve called like this, where here is the delta and this is the power. Okay, this is the P max power, and it usually occurs at when sine delta is equal to 90 degrees. So when you're trying to transfer power more than this, okay, this angle delta is directly proportional to load. Okay, angle delta is directly proportional to load. So if you are increasing your load, delta will increase, so delta will be increasing from 0 to, it will be going forward. So when the load delta becomes 90 degrees, then the maximum limit that power system can transfer is reached. If you're trying to draw more power from that system beyond its level, then what happens? It falls into unstable region. Okay, this region is called as unstable region, and this region is called as a stable region. However, we will make a detailed discussion regarding this thing, but now just keep in mind, okay, this is unstable region and unstable region, and the machine operating on stable or unstable region depends upon the load, which is which influences the delta angle. Okay, so when fault occurs, this delta value will be abruptly or dangerously will increase, and it drives the system into unstable region. So it is very essential that you detect the fault early and disconnect it from the system. Okay, you have to identify which section of the power system is subjected to that fault and immediately disconnect it from the power system. Okay. Now, fault analysis. Okay, what is fault analysis actually, and why do we need it? So study of these fault, the nature of fault, the occurrence of fault, what happens during fault is what nothing but called as the fault analysis. Okay, this fault analysis is a part of transient analysis. You know, basically power system can be studied under two states. One is steady state, another one is transient state. Okay, transient state study has got a number of other studies. Okay, uh, in steady state you study the performance of transmission lines. Okay, steady state performance of transmission lines, and we have something called as load flow study. Okay, they all are they come under a steady state analysis category. In transient state you study about traveling waves, traveling wave analysis. There is a transient analysis. Okay, and this fault analysis, and also stability analysis, all these analysis come under transient analysis condition. Okay, and this fault analysis is also known as short circuit study or analysis, short circuit analysis. Okay, and in order to carry out this short circuit analysis or fault analysis, the load usually will be modeled as a constant impedance. Now what is this load modeling, we will discuss in a later video, but for now it is a very important objective for your exam, that load will be modeled in the form of a constant impedance. Okay, I will make a separate video regarding load modeling. Okay, and what is the need of fault? Okay, need of fault analysis. So it is basically used to determine the values of voltage and currents at different points of the power system at the time of fault, during the fault. And why do you have to determine voltage and current? It will help you to determine the ratings of circuit breakers, and then it will also help doing the fault analysis in selection and design of protection system. Why do we require protection system? Minimize, that is what already I was already telling you. Okay, during the time of fault, number of disadvantages, instability, all these things are going to happen in the power system. Therefore you have to immediately detect it and you have to eliminate the fault. For example, some fault occurs in a human body. Now you can cure it by having medicines or going to the doctor, surgery, and like this. But in case of a power system, you don't have any medicine. If something happens, cut it. Okay, disconnect it. You need switching operation in order to eliminate the fault. For example, there is something wrong on your hand or your finger. We usually apply some ointment, or you take medicines so that it naturally cures. But if you are a power system, then you have to cut your finger. So that's the only thing you have to do in a power system. If something goes wrong, cut it. Cutting in the sense you have to do switching action, and the switching is done by the circuit breaker. Okay, it switches the power system during the fault conditions as well as the normal conditions. We will see how this happens in other lessons. Okay, and then protection system, what actually this protection system has. For example, this is a power system line. Okay, you will have actually a sensor. Okay, you will have a sensor which is also called as a relay. What is the purpose of a sensor or relay? It will sense the abnormal condition in a power system. And in a power system you also have this switching device, what is called our circuit breaker, CB. Okay, you have a CB, and this CB will open or disconnect this faulty line if fault occurs, as sensed by the relay. If fault occurs, relay will sense that fault and it will give a signal to a circuit breaker. You can say circuit breaker is like an automatic switch. It's an auto switching device. Okay, it operates upon the receiving signal from this sensor. So you're automating a power system to protect it. Okay, how you're automating? By placing of a relay or a sensor in combination with a circuit breaker. If relay detects anything wrong, then circuit breaker will operate in order to disconnect the system. Okay, the combination of sensor and or relay with circuit breaker is what called as a switch gear. Switch gear. So you study about switch gear and protection, how to protect a system, what are the different schemes of to protect different components of power system in a different lesson. But however, prior to selection and designing of this protection system, you need fault analysis to be done definitely. Okay guys, thank you for patiently listening so far. Now don't forget, first thing is don't forget to subscribe to this channel for more videos. Okay, if you keep subscribing and keep supporting me, I will be making more videos. Okay, and immediately now like, if you like this video, share with your friends. If somebody are electrical engineering students, or they will benefit from this course, and then comment, immediately comment your opinion, and any suggestions are welcome. Okay, how you felt this course is like, and any suggestions you want me to improve or anything else you want, just put me in the comment section. And finally, have a nice day because you are watching my video. Thank you. Stay tuned for more videos.